Good day, everyone, friends. You're welcome to this channel once again. Yeah, this is Brilliant Minds Academy, and today will be discussing a topic in chemistry, and that is stoichiometry. Stoichiometry is very broad, and the part we'll be talking about is relative molecular mass. How to calculate relative molecular mass. So, starting with the introductory part. Relative molecular mass, also called RMM, is the sum of the relative atomic masses of the elements that make up the compound or the molecule. RAM is for relative atomic mass, while RMM is for relative molecular mass. Relative atomic mass has to do with atoms, while that of molecular mass has to do with molecules and compounds. Now, let's start from relative atomic mass. Yes, we need to understand these concepts before we can go deeper into relative molecular mass. Now, relative atomic mass is just what you call the mass number of an element. Yes, it is gotten by comparing the mass of that element to the mass of one atom of carbon 12. So basically, it is what we call the mass number. Yes, and isotopy can make it possible for some of these mass numbers not to be a whole number. We know some common examples like chlorine, oxygen, and the likes. Now, there is a certain code that you can use for the first 20 elements, odd atomic numbers, even atomic numbers. If the atomic number is an odd number, you multiply by 2, then you add 1 to get the mass number. But if it's an even number, you multiply by 2. There is no addition of 1 in this case. Just the multiplication of by 2 is enough. Yes. But we have some exceptions to this rule. And the exceptions include hydrogen, nitrogen, and chlorine. Please take note that this rule or this code only works for the first 20 elements, with the exception of hydrogen, nitrogen, and chlorine. Hydrogen should be 3, while nitrogen should be 15 if you should go by the rule, but it is not that way because it is an exception. Chlorine is an exception due to isotopy. Now, let's consider some examples. What about sodium? Sodium has an atomic number of 11. So if you should multiply 11 by 2 and you add 1, you are going to get 23. So because that is for odd numbers, that code works for sodium. For oxygen, oxygen is atomic number 8. And when you multiply 8 by 2, you are going to get 16. So this code works for oxygen as well. You can use it as well for phosphorus and every other element you have on the periodic table. You can try them out at your leisure time from element number 1 to element number 20, with the exception of the 3 elements mentioned earlier: hydrogen, nitrogen, and chlorine. Now, these relative atomic masses, like I said, are what you call your mass numbers. Yes, basically for your level of writing UTME, post UTME, WAHEC, NECO, any O level exam. So now let's go to relative molecular mass. The relative molecular mass of a substance can be gotten by the addition of all the mass numbers of the elements in its chemical formula. Yes, I've said this earlier. Addition of the atomic masses will give you the molecular mass. For example, in sodium chloride, you can add up the mass numbers of sodium and chlorine to give you the relative molecular mass of sodium chloride. Now, this relative molecular mass is also called molar mass. Yes, and at times you might be given compounds that have subscripts. Yes, so whenever you have compounds with subscripts, what do? You multiply the subscripts by the mass number. Yes, just the way it appears in the molecular formula. Look at this example. We have CaSO4, calcium tetraiosylphate 6. Because we have 4 atoms of oxygen there, you have to multiply the mass number of oxygen by 4 before you add it or before you sum it up with the other elements. Now it is time for us to take some questions relating to relative molecular masses. And the first question we'll be taking is to calculate the RMM of hydrogen gas. Please, you have to note that hydrogen gas is different from hydrogen atom. Hydrogen gas is H2, but hydrogen atom is ordinary H. So what you are to find here is the molar mass of H2. Yes, the molar mass of H2. And to do this, you just have to impute the atomic mass given to you. Yes, the atomic mass of sodium is of hydrogen is 1. So if you should impute it, 1 times 2 will give you 2. And then we can say that the molar mass or the relative molecular mass of hydrogen gas is 2. For the second example, let's consider calcium hydroxide. That is CaOH2. In this case, I do advise students open the brackets first. Yes, when you open the brackets first, you're going to have Ca plus O2 plus AH2. And doing this, calcium is 40, oxygen is 16, hydrogen is 1. So you multiply them by the subscripts they carry. 40 times 1, 16 times 2, 1 times 2. So the addition of these all will give you 74 grams per mole as the molar mass of calcium hydroxide. Now let's consider those with water of crystallization such as copper sulfate pentahydrate. In this case, the dot there symbolizes addition sign as well. So just follow the normal procedure and separate everything you have there. Copper is 16, sulfur is 32, hydrogen is 1, and copper is 63.5, oxygen is 16. Now when you separate it, H2O is 18. So just multiply it by 5, you are going to get 90. Then you multiply the subscript of oxygen by 16. Addition of everything will give you 64 plus 32 plus 64 plus 90. I hope you understand how those figures are gotten. So when you sum it up, you are going to get 250 grams per mole to be the molar mass of copper 2 tetrasulfate 6 pentahydrate. Now you might also be asked to calculate the mass percentage composition of a particular element in a compound. Yes, the mass percentage of that element is trying to tell you that you need to relate that mass to the total mass of that substance. Yes, for example, you might be asked to calculate the percentage of sodium in sodium chloride. You might also be asked to calculate the percentage of oxygen in calcium sulfate. So to do this, you have to divide the element by the total mass times 100%. Another example is percentage of oxygen in calcium trihydrocarbonate 4. So this one as well, because we have 3 atoms of oxygen, it will be O3 over CaCO3 times 100%. So that means you must have calculated the relative molecular mass before you can get the mass percentage composition of any element you have in that compound. Okay, so if you should do this, let's move on by picking some examples and let's see. Now the first example we want to calculate the percentage composition of each element you have in sodium carbonate, Na2CO3. We have 3 elements in this compound. We have sodium, we have carbon, and we have oxygen. So the atomic masses have been given to you. So the first thing is to find the relative molecular mass, and this we have done. You are going to get 106 grams per mole. Now to get for sodium is 46. How is it 46? We have 2 atoms of sodium, so you have to multiply that 23 by 2 to give you 46 over 106 times 100%. You repeat the same thing for carbon and for oxygen. Oxygen in this case will be 16 times 3, 48 over 106, which is the total times 100%. Now, having done this, you can now proceed to get the approximate value of each mass. That is, for sodium, you have 43.396%. For carbon, you have 11.321%. And for oxygen, you have 45.283%. So when you add up these values you have, yes, the values you have for the 3 elements, when you add them up, you are supposed to get 100%. Yes, 100%. This shows that what you have done is accurate. That is how you can test for accuracy whenever you are finding the percentage mass composition. So, guys, to get this, you have to get the molar mass. Then you can proceed to find the percentage mass composition. So it's as simple as that. So why not take some question or a question as an assignment? Now, this assignment should be done at your leisure time, and you can send in your answer to me through the comment section below. You have to calculate the mass percentage of all elements we have in sodium nitrate. That is sodium triosonitrate 5, NaNO3. The atomic masses have been given. So, guys, if you are done with this assignment, you can drop in your answer in the comment section, and I'll do my possible best to reply to every answer you give. Thank you very much for watching. Yes, please, once again, this is Brilliant Minds Academy. But before you go, please help us hit the subscribe button and make sure you like this video, give it a thumbs up, and turn on your notification button so that you can receive first-hand videos like this. Thank you.